For this extra credit, we were looking at Joule Thief, which allows you to use an almost dead battery to then power an LED that would typically require more than 1.8 volts. Here I was able to actually get it working, and I did get the power of the battery to light the light bulb, which was a success. To start off with the circuit, I found an LED, a 1K resistor, and then I was given a toroid core by my TA because the one that I originally created was not working. So I used this one, and that was my way of being able to get this to light. I then connected the toroid in opposing manner for the base and the collector, and through the resistor, and then through the battery, the positive end of the battery. In this configuration, the toroid allows a magnetic field to be formed through the wires being wrapped in opposing circles. The magnetic field stimulates a voltage in the wire, which is flowing through the positive end of the battery and connected to the resistor. As this happens, this allows the base and the collector to open more so that more voltage can flow through, and then also flowing through the emitter as well. The voltage from the battery plus the magnetically induced voltage allows the base, emitter, and transistor to all be open together. While at first the voltage may be pulling from the coil, causing a magnetic field, after a while this then reverts and becomes a negative. And then after that is when the LED begins to shine, because then now the base and the collector are now closed off from each other, and then the power decides to go the other way around, which now allows it to flow through the LED. Now here I show on the oscilloscope the two separate graphs of the Joule Thief. The top graph shows the LED, and the bottom graph shows the transistor base voltage. So that's what's coming out of the base during the lighting of the light bulb. In the first graph shown, the LED voltage gives more of a spike in my opinion, so I chose to go with that one. But in the second oscilloscope reading that I show, I like the transistor base voltage and how that one looks, because that seems to be more accurate to what we were going for. Here we also see that the period for the LED voltage is 956 nanoseconds, and the period for the transistor base voltage is 960 nanoseconds. The moments where the LED voltage jumps are the moments when the base and the collector connected to the toroid are then closed and allowing the LED to glow the brightest.